Good morning, everyone. Welcome to KP classes. Today's live is regarding you might have seen in the thumbnail that we will be discussing about the glacial geomorphology topics like landforms and depositional, erosional and depositional landforms associated with glacial geomorphology or glacial landforms. So, as we know, KP classes we have been giving geology related coaching from last 8 years. My name is Rukku Raju. I am a faculty geology faculty here at KP classes. Today let's go to the live section and discuss about the geomorphology, glacial geomorphology and the different landforms associated with that. When it comes to the exam point of view, glacial geomorphology is important for GATE, NET and GSI examination when it's added in the IIT JAM syllabus also. In IIT JAM, in match the following related to geomorphology question or MCQ questions, they do ask questions from glacial geomorphology. In UPSC Geoscientist examination also they do ask questions related to glacial geomorphology in detail. In NET examination also they'll come up with some terms, the match the following, or as an MCQ question they will be asking about geomorphology, glacial geomorphology question. We know geomorphology is very important when it comes to NET CSIR Earth-science paper. So this is very, if you are preparing for NET CSIR Earth-science paper or for a GATE geology examination or even for GSI UPSC scientist examination or for IIT JAM geology paper, the topics that we are going to discuss is very important for all the competitive exams. So when it comes to glacial geomorphology, glacier is one of the agent that will be upgrading, that will do accretion, rock fracturing, everything on the whatever rocks they flow on to. Glacier is one among the powerful agent which is very strong in accretion, which is very strong in making different landforms. So for example, if I show you, this is a pre-glacial situation. So this is a pre-glacial situation where the area has not been affected by a glacier now. So you have smooth slopes over here. The slope is very smooth and everything. But when it comes to a glaciation, when you can see that a huge change has happened to the entire terrain. Entire terrain has undergoing some huge changes, and this huge change is because of the erosion and depositional activities that is taken place by the glacier. Erosional and depositional features that done by the glacier. That's what is causing this change in the entire landform. Now, after the glacial event, like a post-glaciation event, the terrain will be completely different from how it was in the first place. There are so many other. There is no smooth slopes present. Everything is very sharp and edgy, and like there are entirely different valley formation has happened. So we are going to discuss about each and every topics, each and every terminologies, each and every landforms associated with the glacier, or each and every landforms that are created by a glacier event. So after this glacier event, if a melt water is being added into the system, like glacier melt water is acting onto the sediments deposited by the glacier, then again there is another set of landform will be forming, that is glacier fluvial landform. In this video, we will not be explaining about glacier fluvial landform. We are only discussing about glacier landform. So glacier fluvial will come up with another live section. So let's start with the glacial landforms over here. So when it comes to the pre-glacial situation, simply there is no event has happened. Now there is no glacial events. A small valley is over here. There is a small river flowing, and these are the smooth slopes. This is pre-glacial. Now, next, this is the glacier event. Now, when it comes to glacier, we can divide the landforms associated with glacier into two. One is the erosional landform, the other one is depositional landform. Erosional landforms means abrasion by glacier is one of the process that causes the formation of a landform. Next process is abrasion and rock fracturing. Both abrasion and rock fracturing combine together to create a particular landform. For example, silk is associated with abrasion and rock fracturing by glacier ice. Whereas when it comes to glaciated valleys like fjord, U-shaped valleys, they are only made by abrasion by glacier ice. So we can analyze, like we can, the different glacier erosional landforms, they can either form by abrasion of glacier or abrasion and rock fracture. Then the next one is rock crushing and non-streamlined relief formations. Rock crushing by glacier ice. That is also another erosional process of glacier. Then normal erosion by glacier by frost shattering mass movement, this residual relief forms will be forming, and that's arrayed, horn, nunataks. We discuss about all those terminologies in detail. So the first one is abrasion by glacier ice. Abrasion by glacier ice. So because of abrasion by glacier ice, the structure, the landforms that we get are streamlined forms. Streamlined landforms. All of these are streamlined relief forms. Streamlined means that will be there will be striations, there will be grooves, or there will be lines present on the structures, and these lines will be parallel to the direction of glacier flow. So if I have a streamlined landform present in a particular terrain, I can analyze that the value of glacial flow direction can be analyzed by looking at this streamline. I'll get a sense of uh, the paleoglacial flow. So when it comes to the glacial striated landforms which are formed by abrasion, the first one is the glaciated valley. Or we call that as glaciated trough. So glaciated trough is a glaciated valley is a glaciated trough. It is a U-shaped U-shaped valley form, and that U-shaped valley is often U-shaped valley, and it should be above the mean sea level. That's the definition of glaciated trough or glaciated valley. They are a floor of which is above the sea level, and that have a often U shape, and this is carved by the intense abrasion of glacier through valley. So over here in this picture, this was a river floodplain over here, a small valley through which glacier flow, this glacial tremendous glacial flow keep on happen and causes formation of a U-shaped valley over here. Formation of a U-shaped valley over here, and that's what is called as the glaciated valley terminology, glaciated trough or glaciated valley. Then there is another type of valley, that is another glacial trough. So glaciated trough can be glaciated valley. Then the next one is glaciated or fjords. Fjords or FJORDS, fjords. Fjords are simple. They are also glaciated troughs, U-shaped glaciated valley, but they are present, like their floor will be below the sea level. Their floor will be below the sea level. They will also have a U shape, like they also will have a U shape glaciated valley. Both of them are glaciated troughs. Glaciated valley terminology is associated with a particular landform that has a floor above the mean sea level. When it comes to fjords, their floor will be below the mean sea level. This is the two differences between glaciated valleys. So U-shaped valleys are always associated with a glaciated terrain. A fluvial situation for making a U-shaped valley, like it required a huge amount of transportation is required to get a U-shaped valley. So for a fluvial system, it's mainly V-shaped, or like get into this U shape, it's very huge amount of work is required. But for glaciated terrain, we mainly get a U-shaped valley in a glaciated landform or glaciated terrain. Now the next terminology is hanging valley. Hanging valley is simple. I have a major trunk valley is there, and there are tributary valleys into this major trunk valley. Over here you can see this is a major trunk valley over here, and there are small tributary valleys in this major trunk valley. So when this abrasion happens, huge amount of abrasion, or the abrasion rate will be higher in this major trunk valley, and the abrasion rate will be lower in this tributary valleys. So what will happen with time? More erosion or more abrasion of this bedrock over here will take place, but comparatively lesser abrasion will happen to this tributary valleys. So if deglaciation takes place, when the entire glacier get removed or melting of glacier happen, these valleys over here, it looks like they are hanging on to the main valley. These valleys, the tributary valleys, they looks like they because prolonged weathering causes for a huge, deeper U-shaped trunk valley over here, and the tributary valleys, the flow will be comparatively lesser. Hence, there there it won't be that deeper as the main valley. Hence, we feel like these tributary valleys are hanging onto the main valley, and those are called as hanging valleys. So, hanging valley is the tributary valley whose floor is sits above the floor of the main trunk valley. That's what is called as a hanging valley. So, if there is glacier present on the hanging valley, we call that as hanging glacier. Then, like during summer season, because of melting of glacier, waterfalls can happen over here along these hanging valleys. So now let's move to the next terminology. Hanging valleys. And next is the whale back or rock drumming. Whaleback is a bedrock. Bedrock actually, like when glacial abrasion happens, glacial abrasion will cause formation of a particular shape. A bedrock will be transferring into a particular shape, and it has the shape of a whaleback. And it's a glacially streamlined rock hillock. Glacially rock hillock having a shape of a having the shape of a having the shape of a whale. That's what is called as whaleback. Now the next thing is striations. Next terminology is striation. Striations, if you have or ever been to a glaciated terrain, you will get to see rock samples that have striations on it, or there are polished surfaces on it. So striations are simply scratch on the bedrock. When this scratch is made by the particles that are carried by the glacier, will scratch the bedrock and causes formation of these striations. Striations will be forming. So with prolonged striation, prolonged scratching by fine grained particle will cause polished surfaces. So glaciated striated terrains are usually polished surfaces because of prolonged scratching by fine grained particle is what causes polishing. Then the next is grooves. If clay size particle or sill size particle under the abrade, that will cause polished surface. If much more coarser particle like a sand size particle will abrade, that will cause formation of a furrow that cut into the bedrock by fragments of rock like glass particles, larger particles. So that is what is called as grooves. So polished surfaces are formed caused by abrasion of fine particles, silt or clay size particle, whereas sand or much more larger rock glass particles abrade to form grooves. So these are the structures or the landforms that are associated with abrasion by glacier ice, and the almost all of these are streamlined forms. Now next one is abrasion and the ice rock fracturing by glacier. Abrasion and rock fracturing by glacier. So these landforms are partly streamlined. landforms are partly streamlined. So the first terminology is silk. 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 Silk is a show you the picture. You can see over here. This is a silk formation. This is also a silk over here. This is also a silk. So silk. Silk is an arm-chaired shaped, steep-walled, semicircular basin in a mountain. Armchair, like we get to see these armchairs in our homes, right? Like where our grandparents sit, like, that have a particular structure. So this semicircular structure is there. So these silks are steep-walled, semicircular, armchair-shaped basins in a mountain, and these are formed by abrasion and rock fracturing by glacier ice, and these are partly streamlined forms. And the relief will be like between 1 meter to 10 kilometer will be the relief feature. Then if two silks, like one silk from here and another silk from here, particularly like they keep on grow. Because of these two silks facing in the opposite direction, and they keep on grow, it causes formation of a low pass over here. Like a pass can be formed in between these two valleys, and in these two valleys, and that is what is called as a fold. Okay, that is the low pass or low pass connecting the two silks facing the opposite direction. That's what is called as a fold. Next terminology is Roche mountains. Okay, mountains. These are also landforms associated with abrasion and fracturing. So what's happening over here? When it comes to rocky mountains, these are bedrock feature. If there is a bedrock present and onto which glacier flow is happening. So imagine there is a bedrock is present over here, and upon the bedrock, like the glacier flow is happening in this direction. So what will happen? How the glacier erosion takes place? Glacier will smoothen the store side, and it will like abrasion will be happening to the store side of the bedrock, and the lee side will be undergoing rock fracturing. Rock fracturing will happen to the lee side of the bedrock. So if the bedrock is like this, it's like this. So this store side is completely smooth, and this is how the flow direction will be. So this is a bedrock feature, and it generally has a length, or the dimension can be 100 meter, more than 100 meter long, and this the long axis will be parallel to the glacier flow, or the movement of ice will be parallel to the long axis, and the peculiarity is that the the up ice side or this store side will be completely polished or streamlined and smooth, whereas over here in the lee side, rock fracturing, plucking and fracturing will happen, hence it will be much more rugged. The store side will be gently dipping, lee side will be steeply dipping. This is how a rocky mountain looks like. A much more larger variety of rocky mountains can have a dimension of 100 meters or more. So if this one is more than 1 kilometer, like more than 1 kilometer long feature, we call them as flick wells. Flick wells are the rocky mountains, only the streamlined bedrock feature, which have a smooth store side and a rugged lee side is there. And when it comes to their dimension, if they are almost 100 meter or more than that, we call that as rocky mountains. And if they are much more larger in dimension, their dimension is greater than 1000 meters or 1 kilometer, we call that as a flick well. Then the next one is crag and tail. Crag and tail. So what is crag and tail landforms? Crag and tail landforms are simply if a terrain has both Imagine this terrain over here. If there is a bedrock present, this much the area is both a resistant rock and a weak rock is present in the terrain. So there is a bedrock present. This way, and this bedrock is surrounded by a limestone. Okay, this is a limestone is present on the either side of the bedrock. So what happens is if glacier flows over this one, glacier will erode. This side will be eroded by glacier. Over here, limestone will be completely eroded, and this part of the rock will also be eroded, and it will be deposited in this. This is a resistant rock, right? So the glacier won't be able to transport this resistant rock grains. So whatever particles that are eroded, that will get deposited over here in this limestone rock in the stores in the lee side. This is how the glacier flow happens. So what happens with time? Actually, there is the entire limestone over here got eroded, and the rock. This one will have a steep slope over here and a gentle slope in this particular side. A gentle slope over here, and this limestone has been preserved. With time, if this limestone is keep on eroded, but this side the limestone will be preserved because of that resistant rock being deposited. So how will it look? With time, there will be like a steeper, rugged lee side and a smooth rugged toe side and a smooth lee side, and there will be like this limestone will be preserved over here. Limestone rock which is preserved over here. So this is the crag, and this side, this is the tail part is called as the that is the tail, and the resistant rock dome over there is called as the crag. That's what is called as crag and tail. So crag and tail is an asymmetrical landform, and it's comprising a rugged crag and a smooth tail. So it has a particular, like if I draw Roche Mondonis will be like it has a smooth store side and a rough lee side. This is Roche Mondonis. This is the ice flow. And when it comes to the crag and tail, it has a rough part over here in the store side and a smooth tail is present. So the both of them have an entirely different direction. Like if I have a Rocky Mountains, the upside side of the glacier will be the smooth store part, whereas when it comes to crag and tail, the upside glacier ice movement is this rugged store side. So this is very important to identify. Like it's very important to identify whether we are discussing about the crag and tail or Rocky Mountains, and about the structure. Crag and tail will be easily identified by looking at this tail particular feature. I hope the voice is clear for everyone. The audio is clear. Let's continue. Now, next structure over here by abrasion and rock fracturing is done. Next is rock crush structures. Abrasion, rock crush by crushing by glacier. This is the erosional process. The erosional process is rock crushing by glacier, and these are non-streamlined forms. Non-streamlined forms, and these non-streamlined forms have comparatively smaller in dimension. The dimension is comparatively smaller. Now when it comes to the rock crushing, first terminology is arrate. Arrate, form, attacks, completed spur. All these are the different terms. So, question by question. Rock crushing terminology is rooted fracture. First term is unit fracture. So I told you rock crushing or non-streamlined landforms are comparatively smaller in dimension, 1 centimeter to 10 centimeter dimension. And this unit fracture means it has a crescent shape fracture. It is simply a fracture, a crescent shaped fracture, and that have a concavity facing direction of the flow. Like the with the concavity facing the direction of the flow is called as lunate fracture. Then the next one is crescentic fracture. Crescentic fracture is much more smaller, crescent shaped fracture with the concavity facing away from the direction of the glacier. That's the difference. Lunate fracture is having a concavity facing fracture, crescent shaped fracture, and the concavity is facing towards the direction of ice flow. Crescentic fracture is comparatively smaller, crescent shaped, and crescentic fracture, their concavity is facing away from the direction of glacier flow. Next one is erosion by glacier ice. Erosion by glacier ice, like normal by frost shattering, and mass movement. So these landforms are associated with residual relief of 100 meters to 100 kilometers, 100 meters to 1000 kilometers. That much huge dimension they have. The first one is arrate. Arrate. Then second one is fault. Let's see what is an arrate means. You look over here. This silk formation, we discussed what is a silk. So prolonged erosion of silk from different sides, and that causes formation of a narrow ridge, a knife like edge will be forming. Imagine from this side this silk is forming, this side another silk is forming, which causes formation of a narrow knife like ridge formation, sharp edged ridge formed, and that which is separating the two silks, and that is what is called as an array. A narrow, sharp-edged ridge separating two silks is called as an array. Next terminology is horn. H-O-R-N. Horn. Horn is horn. Horn is a symbol like if there is more than three silks are there, three or more silk formation is there, that causes formation of a peak. One silk is in this side, another is over here, another will be the other side. This causes formation of a peak on the top. And this peak formed by the intersecting walls of three or more silks is called as a horn. So horns are also, these are very important terminologies. Horn, array, and these are very important terminologies. Next, third one is nunatak. Nunataks are, it's not shown over here. Nunataks are unglaciated island of bedrock. Imagine there is a huge bedrock was over here. A huge bedrock was present over here. And the glacier is not touching this top of the bedrock. Like this top part of the bedrock is not touching the glacier. So this bedrock is not being eroded by glacier, or there is no glaciation is happening on this particular bedrock, and that's what is called as a nunatak. Nunataks are a very large dimension bedrock that is exposed outside or exposed to the surface, and that is formerly or currently will be surrounded by some ice, but they are unglaciated island of bedrock. They are not being eroded by any bedrock. They are completely not being in touch with the glacier. That's what is called as a nunatite. Fourth one is a truncated spur. Truncated spur, you can see over here, this is a truncated spur. So truncated spur are simply the valley side, a triangular shaped ridge, that is ridge valley side is what is called as a truncated spur. This triangular shaped valley ridge over here, no, this is what is called as a truncated spur. In the UPSC they gave four options related to truncated spur and they have asked what is a truncated spur. So it was mentioned over there in the option, like it is simply that triangular shaped uh, feature that is present. Like the definition was the steep sided, the lower part of the ridges that have been carved into triangular facets by glacial erosion. This is what is called a truncated spur. So that's what is shown in the picture over here, truncated spur. So these are the landforms that are associated with erosional activity or erosional land erosion of a glacier will cause formation of these landforms. Now when it comes to deposition, even depositional event, a glacier deposited sediments. A glacier deposited sediments are called as that they are actually called as till sediments. A glacier deposition. Till is the sediment that has been deposited by glacier. There are some 8 characteristics of till which is very important. All till deposits are always poorly sorted. Poorly sorted sediments. They lack any stratification. If this glacier deposited sediment or a till sediment, if they are reworked by a glacial meltwater, if these sediments are reworked by a glacial meltwater, that will cause stratification or better sorting on these sediments. That's what causes formation of cave and kettle depositions and all those structures, glacier fluvial landforms. If they are glacier fluvial, we get stratifications. If the deposition is only by a glacier event, then there will not be any stratification present in the sediments. Like there will not be any graded bedding won't be there, laminations won't be there. All these structures, like all these stratifications are absent in a glacier deposited till sediment that we get. Then usually we have a mixture of ecologies. Mixture of lithologies in the till deposit. Why? Because glacier is simply being dumped by whatever the sediments are there, they are deposited, laid down by the large ice sheets. So there is no particular sorting is not being done, or removal of fine clay particles are not being done. So there is no sorting is happening. Hence there is a mixture of ecology is what we get in a glaciated till deposit. Then we mainly get faceted particles or angular particles are very common. Faceted angular particles are very common, and these faceted particles are will be streamlined. They will be streamlined. Streamlined faceted particles are very common in the till deposition. Next one is all these particles, they have a preferred orientation. They will have a preferred orientation, like they will be aligned in the direction of glacier flow. A preferred orientation will be there, and there is compaction associated with the pressure developed during deposition. Compaction will be happening associated with the pressure during the deposition event. Next one is it is still deposition will happen upon a striated rock or a sediment basement, because Upon that surface, the glacial flow might have happened, right? So upon those striated rock body, sediment deposition or till deposition will be happening over a striated rock body. Then the last one is, I have already mentioned about the faceted particles are angular, subangular particles. Mainly associated with till deposits are mainly associated because predominantly having a subangular particles will be there in the sediment, like in the till deposition. Subangular particles will be there because of this fracturing and rounding by abrasion. Abrasion will cause rounding, but fracturing will cause formation of angular grains. Hence, we have a subangular particles will be there in the glacial deposition. Subangular particles will be there in the glacial deposition. So these are the characteristics of till deposits. Till is the sediment laid down by glacier. The deposition, the sediments laid down by glacier is what is called as till. Till, these are the characteristics of till. They are poorly sorted. They lack the stratification. There is no lamination or graded bedding present. They do contain a mixture of lithology. Faceted particles which are streamlined will be present in the till deposit. And all these particles will have a preferred orientation. They will be during deposition. The pressure acted by during the deposition will cause um, compaction. And the last one is this: they have, because of both abrasion and rock fracturing acting upon these particles, they will be subangular. Their angularity is subangular. They are subangular particles. So these are the terminologies, or these are the definition or characteristics of till deposit. We'll come up with another live defining the depositional landforms. The detailed depositional landform of glacier will be explained in the continuation of the next live section. So I hope the entire terminologies, erosional landforms are clear for everyone. The terms, the erosional landforms formed by abrasion activity, and though if abrasion is only happening, those will be streamlined forms. Then abrasion and rock fracturing by glacier causes formation of some of the landforms, and those will be partly streamlined because there is rock fracturing is also happening. Then the next one is rock crushing. Rock crushing causes formation of uh, non-streamlined landform formations which are very small in dimension. Then the next one is the normal rock shattering, mass movement or erosion by glacier causes formation of landforms which are much larger in dimension, 100 meter to hundreds of kilometer dimension landforms like horn, arrayed, nunatak, truncated spur, etc. And I also discussed about the tail sediment characteristics. So these are the terminologies associated with glacial eroded landforms. So thank you so much for joining the live session. We'll be coming up with the next live for the depositional glacial landforms. So if you want to join in KP GATE classes for GATE or GSI UPSC Geoscientist paper, or for next CSIR examination, or for IIT JAM Geology preparation, join us. All the details are provided in the description box. You can contact us. You can fill out form for a trial class. Along with the online lectures, there is offline classes are also available. Recorded lectures will be provided to you through our GATE, KP GATE application. Recorded lectures will be provided to you. Study materials can be availed both in online or in or offline form, like as a printed format or as a online soft copy. You can avail the study materials. Test series and mock tests will be given to you 1 month prior to any competitive examination. There will be a mock test prepared by us, and you can attend that. The minimum 3 mock tests will be given for each competitive examination, and there will be test series of more than 2000 questions there in this test series. And like if you want to come over here and attend the offline class, there are hostels and all these facilities are available near to the coaching institute only. So if you want to join our coaching, if you want to attend the classes in detail, so please come join us. Please contact us in the details in the description box. Thank you so much. We'll meet in another live session.